Okay, good morning class. So at this point we had homework, correct? And the homework was on page, which page were we on? Anybody can give the page number, okay? Which page were we on, people? 40. 66. Is that your let's go to the simultaneous equations first. Was there any problems there?
Yes.
Okay, the simultaneous equation was on page. Sure, it's on page 51. 51. This is exercise 2.15. Which was the problem? Which sums was problematic to you guys? Sorry? 15 and 16. Didn't we do 15 yesterday? Okay. 15. Yes, your nature of roots is here, that's why I kept that thing. Okay, so it's 17. This is exercise 2.15. Page 51. Simultaneous equations. Okay. So, the first thing is we must make it the subject of the formula. So that means x is equal to 5y minus 3. If I say x, I put the 5y minus 3, so it's 5y minus 3 squared minus y squared is equal to 45. First term squared is 25y squared, that times 2, it's negative 30y. Plus 9 is minus y squared is equal to 45. So y squared minus 25y squared minus y squared is 24y squared minus 30y minus 36. Now, so as you can see, 6 can be divided throughout. So it's going to be 4y squared minus 5y minus 6 equals 0. Not so? So you can go into your factors, or you can just use your quadratic equation. So it's going to be minus b plus minus the square root of b squared minus 4ac, sorry. 4a is 1, 4, and you see is negative 6 over 2a. So I'm going to give you an answer of 2. Or y is equal to. So what happens is, we use the quadratic formula so often that we tend to write x is equal to 2 and x is equal to negative 3 over 4. Watch out for a mistake like that. Okay. Where's your mistake, Michael?
I added y squared instead of minus y squared. Then substituting.
Oh, this your mistake is here. Okay, no problem. So therefore x is equal to 5 times 2 minus 3, which is 10 minus 3, which is 10 minus 3 is 7. On the other hand, we have x is equal to 5 times negative 3 over 4 minus 3. Negative 15 over 4 minus 3 is 12, is negative 27 over 4. Is that correct? Huh? Right. Okay. Any other problems with the simultaneous equations? 16. Again, we need to make either x or y, the subject of the formula in the linear equation, definitely x, so x is equal to 2y minus 1. Wherever I see an x, I put the 2y minus 1. So it's 2y minus 1 squared plus 2y into 2y minus 1 equals y squared plus 2. The binomial squared is going to give you 4y squared, that times 2, it's negative 4y plus 1 plus 4y squared minus 2y equals y squared plus 2. Okay? So 4y squared plus 4y squared is 8y squared minus y squared is 7y squared. Minus 4y minus 2y is minus 6y. 1 minus 2 is negative 1. Either quadratic equation, or we can factorize. That's going to give you negative positive, so y is equal to negative 1 over 7, or y is equal to 1. Then to get a corresponding x value, I substitute that into that equation there, which gives you 3. So y is equal to 2 times negative 1 over 7, which is negative 2 over 7. Minus 1 is negative 1 and 2 over 7, or negative 9 over 7. On the other hand, we have x is equal to 2 times 1 minus 1, which is 1. So what was the problem? Who asked this question? Where did you go wrong here?
Positive 2y and 2 negative 2y.
Positive 2y. Where?
The third blue line.
So you got positive 2y. Okay. Anybody else made a mistake on the side? Okay. Where did you go wrong? Which line? The very first one. So you wrote x is equal to? Or you wrote down the question wrong. Okay. Anybody else? Any other problems with the simultaneous equation? Okay, so the simultaneous equation is behind us now. Okay. Will come in this exam, your mini exam, and every major exam after that for 6 or 7 marks. So keep on practicing. It's worth knowing how to do it. Because besides coming in question 1, it comes in at other sections as indicated in the prior lesson. Okay. Then what else was homework was the nature of roots. Not so? Okay, so let's go there quickly before we go into the word problems. The nature of roots. It was exercise 8 on page 300 and page 36 in the Mind Action series. People, any problems with numbers 1, 2 and 3? 1 to 3. Any issues here? You guys did the homework, no? Very important to do this. So if this question come in, many learners leave it out. Okay, and it's unnecessary. Why are you leaving it out? It's easy. If you apply the rule. The same steps get applied all the time. Okay. So any problems with numbers 1 to 3? No. Okay. Then I gave you to which number to do? 6. 3, 4 and 4, 5 and 6. Any issues here? 6. Okay. Anything else? 5. So let's do 5 and 6. Okay. For homework is the remainder of that exercise. Okay. Then we'll put that behind us. 5 and 6. Here we go. So number 5, the question says, show that the roots. Okay, now this is a show that question. It don't ask you for which values is the root, for which values of P is the roots non-real. This is different setup as we had before. The question is, show that. So it is already, we know the fact of the matter is the roots of the equation x squared plus p minus 2x plus 1 minus p is equal to 0 are rational for any real value of p. So, in a show that question, we can't use the fact that p is rational, or the roots of the equation is rational. We must end of and conclude that it is rational. So, is this equation in the form of ax squared plus bx plus c? Is that in that form? Yes. What's your a value? 1. What's your b value? P minus 2. What's your c value? 1 minus p. How do we get a? A is the coefficient of x squared. How do we get b? B is the coefficient, the number in front of x. Now how do we get c? C is the variable, the coefficient. No, the constant. I'm saying that the whole time around. No? I said yesterday as well. But what is your nature of roots dependent on? It's dependent on delta, which is b squared minus 4ac. What's your b value? P minus 2. Not so. So it's p minus 2 squared minus 4. A is 1 and your c is 1 minus p. So when a binomial squared is going to give you p squared. That times 2 is going to be negative 4p plus 4. That's going to give you negative 4 times 1 is negative 4. Negative 4 times negative p is positive 4p. So it's going to be p squared minus, that cancels, that cancels. So it's actually p squared. But what do we notice here? That p is a perfect square. Can you see that? So since p, since p squared is a perfect square, therefore roots are real, rational, and it could be equal or unequal. Depends if p is 0, it can be equal. But they wanted you to just show that it is rational. So there we have shown that it is actually indeed rational. Yes, Michael?
Oh no, I figured out the
Where did you go wrong?
the p minus 2 squared, like that calculation part.
So this part here you got wrong.
Yes, I got p squared minus 4.
Yeah, remember it's u squared that and that. Rather write it out twice, you multiply it out, you shouldn't make a mistake. Okay? But the rule is you square the first term, you say p times negative 2 times 2, which is negative 4p. The learner always messes that up. It's either you remember the rule or you're messing it up now and then. Always play it safe, write it out twice, multiply that, you should get it done. With regards to number 6, in number 6 we are told show that question. Okay? Show that the roots of the equation r plus 1 all squared plus 4 plus 1 equals r are real for all real values of r. First question, is this in the form of ax squared plus bx plus c? Is that equation in standard form? Is the equation in standard form? No. We must bring that r over. It is r plus 1 x squared plus 4x plus 1 minus r is equal to 0. Now is it in standard form? Yes. This being c. So what is your a value? R plus 1. What's your b value? 4. What's your c value? 1 minus r. You guys see that? So delta is b squared minus 4ac. What is your b value? 4. 4 squared minus 4a, r plus 1, c, 1 minus r. From here it's a matter of simplifying, so it's going to be 16 minus 4 into, it's a conjugate pair, I can multiply the first and the last. I swap that r plus 1, 1 plus r is the same thing, so it's 1 minus r squared. Multiply that out, I get 16 minus 4 plus 4r squared. Which simply gives us 4r squared plus 12. But 4r squared plus 12 is a quadratic. If this equation was y is equal to 4x squared plus 12, and I had to draw a graph for that. Remember last time we drew these graphs. What is your y-intercept? 12. Not so? The graph smiling or frowning on this parabola? Smiling. So it has a minimum value. Can you see that? So can delta ever be negative? This is y is equal to 0. What do you know about delta? Or about this graph? It is always positive. Can you see that? So if I replace the y with delta and x with r, then this is your r here and this is your delta here. Can you see that? So is delta ever negative? No. So delta is always positive. Is it ever 0? No. So can the roots ever be equal? No. Can the roots ever be non-real? When is the roots non-real? If delta is negative. Is delta ever negative? No. So what do you know? The delta is always greater than 0. Which means to say it will be unequal. The question says, show that the roots of the equation are real for all real values of p. So you say since, we state the obvious. We say since delta is always greater than 0. So always just check here. Since delta is always greater than 0. Or you could have said since delta as a minimum value of 12. Okay, since delta has a minimum value of 12, therefore, which means to say then in the resulting always be positive. Okay, since delta has a minimum value of 12, therefore roots are real. I just asked you for real. Roots are real for all real values of. That's one way of answering. Or we could have said as follows. Okay? If we take delta, which is 4r squared plus 12, you see, whatever method you use, that remains the same. Your conclusion is just a bit different. With different ways you can represent your answer. Okay? You see, if we're looking at r squared will always be greater than or equal to 0 for r is an element of real numbers. What does that mean? That means to say whichever value you choose for r will always be greater than or equal to 0. Why? Because if you choose a negative number squared will always be positive. If you choose 0, then it will be 0. Not so. Even if I put a 4 in front there, it will always be positive or greater than, it will always be 0 or greater than 0, which is positive. So the smallest value that 4r squared can ever be is 0. Not so. But what do we do if we plus 12 to it? It will always then be greater than 0. The smallest value this can ever be is 12. Can you see that? So, we can say therefore, the roots are real for all real values of. Okay. Either way you can do the conclusion. I think this is the easy one, no? Okay. We'll do another, do the homework, then we'll look at another one or two of this tomorrow. I see you keeping your head. No? Yeah. The last part's confusing. Alright. do the homework, and then tomorrow we'll look at the conclusion of another two. Okay. But I need to get out to the one sum I had a problem with yesterday. Did I made a mistake on? I marked the wrong length, no? So let's go here. Then we're going to look at the this is the reference, no? Now to exercise 2.17 on page 65, no? Is that correct? Right, so we are told the workshop is rectangular and measures 9 by 7. Okay, so we say that that is going to be 7 meters. Your breadth is always your shorter one, which in this case was your width, no? And this was 9 meters. Then we are told it's measured by 9 by 7, and we say the area of this is going to be 9 by 7 is 63 meters square. Then we are told in order to cope with the growing demand of the business, the owner plans to increase the area too. So the area of the second piece now is going to be 180 meters square. By increasing the width by x. Okay, so we said that since that is the width, okay, so he's going to increase the width here by x, and by x, and the length by 2x. Okay, and then we're going to get a new rectangle. Not so? Is that correct? No? So if this is 7 and that is x, then this length is going to be x plus, not 7x. Who's saying 7x? What's wrong with you? You're going to get x plus 7, and this here is going to be, since that is 9 and this is 2x, it's going to be 2x plus 9, or 9 plus 2x. You all okay with that? So the area 2 is given as 180 meters square. So we can set up our equation. So therefore, put this on the inside. Therefore, the area of the second piece is going to be, how do you calculate area? Length times breadth, not so. So it's going to be 180 is equal to x plus 7 into 2x plus 9. Which is going to give you 2x squared, which is 9x plus 14x is going to give you 23x. Is that correct? 23x. 7 times 9 is 63, not so. And 63 minus 180 is negative 117. From here we can use the quadratic formula. The quadratic formula, quadratic equations formula is minus b, which is negative 23, plus the square root of b squared, square root of b squared, minus 4ac over 2a. Two times 2. We give you 3,81. Is that correct? Sorry? 3,82. 3.82. For the other one, we replace the plus with a minus. Negative 15,32. But that, your length can't be negative. Not so. So read the question. The question says find the dimensions of the new workshop. So the length and the width, of course the width is going to be the longer one. So it's 2 times 3.82 plus 9. There's actually your length. And your width is going to be 3,82 plus 7. That is 10.82 meters, not so? And this one here? Sorry? 16,64 meters. People, any issues there? Yes. Round off is fine. No, that's a bit too drastic. 1 decimal would have been suffice. But normally in the exam you must tell you on top. Round everything to 2 decimal places unless stated otherwise. So you're right, everything to 2 decimal places. Okay. Unless the question specified to 1 decimal, then 4 would have been good. Alright? Sorry about this one from yesterday. I thought I was going to be a bit faster than usual, but they brought us the wrong answer. People, with regards to the homework I gave you, exercise 2.17, I gave you a set of numbers to do, not so? And that numbers was what? You had to do 2. Any problems with 2? Yes. 3?
Yes.
Did you watch the video again? No, that's a problem.
Okay, so listen.
Listening, yes.
And I didn't find that question. I didn't find it.
How could you have not? How do you mean the video? How can you find number 2 in the video? That number 2 wasn't done yesterday.
Exactly, I do understand.
But the example was done.
I know that.
Did you watch the example a few times?
Oh, it's like why?
Once is not good enough. Once you saw me, must do it once. But I'll do it in future. Please watch the video, because I now won't be able to do 2.16, which is also coming in your exam. But okay. It's easy to say yes, 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 yes. But have you actually taken time out to go learn how to do it? No. Okay, so I gave you numbers 2, 3, the numbers I gave you was 2, 3, 11 and 12. Okay, what other problems did you have? Who got 2 and 3 right but not 11 and 12? Not the case. Okay, so I'll do 2 and 3. Okay, so we are told that a group of grade 11 learners decided to have a party. The total number of money spent on food and drinks was 2,295. 10 of the learners could not have. So the number of learners is unknown to us. Not so. So we say let the number of learners be X. Okay. Then the total money spent on food and drinks was 2,295. So how do they get that? The total number of learners multiplied by the contribution of each learner. Not so. So we say the contribution of each learner be 1. So then in that case I can set up my first equation. What's my first equation? X times y is equal to 2,295. That's how we would get our first amount. Then the story goes on. 10 of the learners cannot afford to pay. So what does that mean? The number of actual learners that's actually paid, number of learners who actually pays, is going to be X minus 10. The other learners in the group agrees to pay an extra 50 Rand So what does that mean? The contribution of each paying learner. Learner would be now what? Y plus 50. Not so. But if you multiply the number of learners paid and the number of the contribution of each learner, each paying learner, if I multiply that together, what should I get? X minus 10 times Y plus 50. That should foot the bill, cover the bill of 2,295. Okay. From there, it is a matter of simultaneous equations. Okay. Yes? You see, if say we be 10 in a 20 in a class, okay, and 10 can't pay. How much is paying? 10. It's 20 minus 10. If it's 20 learners and 2 is not paying, 20 minus 2. 15 learners, 20 learners, 15 not paying. 20 minus 15, which is 5. 20 learners, X not paying. 20 minus X. X learners, 10 not paying. X minus. That's how we get this here. Number of learners paid. Okay. Then, contribution of each paying learner. Each learner is paying 50 Rand more. Therefore, it's going to be Y plus 50. From here, it's a matter of solving the equation. I'm going to make Y the subject of the formula here. Y is equal to 2295 over X. So wherever I see a Y, I put that. So it's going to be X minus 10 into 2295 over X plus 50 equals 2295. So what do I do from there? It's a matter of solving the equation. So that's going to give us, you multiply that out, so I say 2295 plus 50x minus 22950 over x minus 500 equals 2295. Multiply throughout by x, get rid of the denominator, is 2295x plus 50x squared minus 22950 minus 500 x equals 2295x. This simplifies into number 6. The number is number 3. Number 2. So I got, work this out, 50x squared minus 500x minus 2295 equals 0. Yes? Negative 10 multiplied by that. Isn't it? Not it's a 0, no? No problem. So that's going to give you 27 or x equal to negative 17. I use the quadratic formula there. Of course it can't be the negative 17. So coming back to the question was calculate how many learners in the group. So in other words, you're calculating x. So there are 27 learners in the group. Okay. Let's do the next one, number 3, no? What's the next one? Okay, number 3. Number 3, we are told a farmer buys a number of sheep for a total of 160,000 rand. He buys a number of sheep. So what do? We say, let the number of sheep be, okay. So then, cost per sheep, we let that equal to 1. Okay. Can we set up the first equation? Yes. So what will the first equation be? X times y is equal to 160,000. Okay. Let's go and make y the subject of the formula. So it's 160,000 over x. Okay. We got 2 unknowns, so we must generate another formula. 15 of the sheep are killed by the leopards, by leopards. And the farmer sells the remainder sheep. So 15 is killed by the leopards. So number of sheep sold would be what? X minus 50. Then cost, selling price per sheep would simply be, he sells the remainder sheep for 2,500 rand per sheep, more than the original price. That was the original price. So it's y plus 2,500. And still makes a profit of 2,500 in total. So in other words, the second equation consists of number of sheep sold, which is x minus 15 times y plus 2 and 2,500. And that would be give you a return of 160,000 rand plus 2,500 profit. Can you see that picture? From here, it's a matter of solving the equation. So is this work so difficult? I think the part where you need to set up the equation, you need to master that. Once that is mastered, the rest you can do. Okay. So that's going to give you 162,500. Okay, we multiply this out. I get once this was multiplied out, I get 160,000 plus 2,500 x minus 15 times 160,000 minus 37500 equals 16250. Okay. This works out to be simplified as 2,500 x squared minus 40,000 x minus 15 times 160,000. So therefore, x works out to be 40, or x works out to be negative 24. It can't be negative 24. Okay. On the question again, the question was, how many sheep did he buy? He bought initially X amount. So in other words, he has 40 remaining. And he bought 40 sheep in total. Okay. So what I'm going to do is I'm going to give you a chance to redo for homework. So I did number 2 and 3 now. So I'm going to give you a chance to do 11 and 12. Okay? So tomorrow I'll do one of the two. Don't tell me again all of it. If you don't understand both, then I can't help. Everybody don't understand it. But if it's one of the two, then I can do one of it. Okay? Otherwise, I'm sure you should be able to do it if you watch the video again and again. Okay? That is the idea why we're doing this thing, isn't it? Then we need to now do example 3. Example 3 is a distance, speed, time question. Okay. This is example 3 on page. Example 3 on page 62. Example 3, page 62. Now again, there's many ways of approaching this thing. Okay. The previous one, there's another method that you could have applied here. There's a formula that they use, which is actual is equal to original plus minus your difference. That form is actually easier to use than what we are using here. But to show you two different ways at one time is not going to make sense. Okay. So if you guys can master this method on the next two, then I can just show you how that formula actually works. Okay. We normally teach that in advanced maths. Okay, that formula. All right. But like I say, if you can't get the one, what's the use? We're teaching you two different methods. Okay. It's easier in terms of, if you understand what you're reading, it's going to be easier. Like the things of two steps ahead already. But you'll see tomorrow. If you can master that method, then I can just show you how you apply that. Okay. Otherwise, if you have any problems, then I'm not going to show you, and then I need to do one or two of the examples. Okay. People, example 3 on page 62. We told that the pilot flies a small plane 420 kilometers from Johannesburg to Nelspruit. So whenever we get this question, we draw a table. Not so. Always draw a table. Okay, so we draw a table. So we're going from Johannesburg. Always making this small. It's fairly large there. Okay, so you got your distance, speed, the distance, the time, and your speed. So you're going Johannesburg to Nelspruit, Nelspruit to Johannesburg. It always will be a return. Okay, you got your distance, your speed, and your time. Then in grade 8 and 9, we use the triangle. What goes on top? 30. Yes. Not so. When you get your speed, distance, time question, this is the setup, without reading further. So as you read, we start populating. Okay. Just in case you tell me you don't understand all the steps. No? It's recorded. No? Watch it. It's very confusing. I understand it's confusing. But you must practice it. It's the only way you're going to master it. So you tell the pilot flies a small plane 420 kilometers from Johannesburg to Nelspruit. So it's 420 kilometers. So how many kilometers is it from Nelspruit to Johannesburg? Huh? 800 kilometers. If it's 420 kilometers from Johannesburg to Nelspruit, how many kilometers is it from Nelspruit to Johannesburg? Yes, also 420 kilometers. Not so. Then we are told on the return journey with an additional load and a headwind, the speed is 90 kilometers per hour slower and takes him 30 minutes longer. Okay? So what is the unknown here? Is the speed. Not so? Because on his return trip he has an additional load, so the load is heavier. And the wind that affects the plane is 90 kilometers per hour slower. So going up, we say let the speed, the initial speed, equal x. Let the initial speed be x. So there is x. Not so. So what will your time be? What we do is we close the t. Then what do we have? T is equal to d over x. Distance over speed. You all okay with that? Who doesn't understand? You all understand, huh? What don't you understand? You understand for now. So you're putting up your hand, you understand for now. No, so she. Yes, what do you say? What don't you understand?
Okay, so speed x because
it was unknown. Because here, remember they're saying that the return trip is 90 kilometers slower than it took up the initial trip. From Johannesburg to Nelspruit is not given. But from Nelspruit to Johannesburg,
x minus 9.
yes, that's where we get it. Anybody else that's confused? Okay. So what is the time? To calculate time, close t is d over s. So what is your distance? 420 over x.
Good morning, may I have your attention,
You all agree with that?
Ilham Isaacs and Tiana van Wyk can please report to the office for a collection. Ilham Isaacs and Tiana van Wyk, please report to the office for a collection.
Okay. Let's close it. So what happens is, okay. Now, if the returning is 90 kilometers slow, so it's going to be x minus 90. X minus 90. So to work out your time, your second time, t2, is again going to be d over s. So what's your distance in that case? 420 over x minus 90.
Good morning, may I have your attention, please? We need everybody's attention with regard to the learners who are donating blood. There's a request that you need to have a proper meal before you go into the hall to donate blood. You need to have a meal before you go into the hall to donate blood. Thank you.
Okay. So, you all okay with that? Yes. Right, so we carry on the reading. Remember that your speed is normally kilometers per hour. So if you are given it in minutes, you must convert it to hours. Okay. So here we are told slower and the trip takes 30 minutes longer. It takes 30 minutes longer. Which means to say, if I subtract the larger time, the bigger time, minus the smaller time, it should give you an answer of 30 minutes. Why? Because the difference between the two is 30 minutes. Does it make sense? So, which one takes longer? Johannesburg to Nelspruit? Or Nelspruit to Johannesburg? Nelspruit to Johannesburg. Okay? So what we do is we say, that's going to take longer, no? So it's going to be 420 over x minus 90. Here's the other way around. You just check. Yeah, it's right. Minus 420 over x is equal to 30 minutes longer, it's 30 over 60. Not so. That's how I get off. Okay. From here, it's a matter of solving the equation. Okay. If this is going to come wrong, this is. But let's just check. Then we can relook at it. Okay. So what's my LCM here? Is 60x into. Okay, let's just make this half, so it will be a bit smaller. Okay, it will be half. So your LCM is going to be 2x into x minus 90. So this here must be multiplied by 2, so it's 840 into x, not so. So this must be multiplied by 2x minus, this must be multiplied by 2, which is 840 into x minus 90, and this must be multiplied by x into x minus 90. So that's going to give you 840 minus 840x minus 840x is gone. So 0 is equal to x squared minus 90x. Now negative 840 times negative 90 gives you an answer of positive . So this comes to be a negative here. No? So a negative times a negative is a positive. So 840 times 90 is what? 75,000 something. Now, so that's going to be a positive value. You take it over the equal sign, it becomes negative. Negative what? 75,600. So use the quadratic formula. A is equal to 1, B is equal to negative 90, and C is equal to negative 5,600. Negative 75,600. So we punch that in the calculator. Into your quadratic formula is minus B, so it's negative 90, so it's 90 plus the square root of 90 squared minus 4 times A, which is 1, times C, which is negative 75600. And that is over 2 times A, which is 1. Gives you an answer of 323,61. 323,61. Or we replace that plus with a minus, which is negative 233. X is equal to negative 233, comma 61. But can the speed be negative? No. So reading the question says, calculate the time taken for each journey. So in other words, I must calculate the time from Nelspruit. Let's call this T1 and T2. So T1 from Nelspruit, from Johannesburg to Nelspruit is going to be 420 over 323,61. And then the time taken from Nelspruit to Johannesburg is going to be 420 over 323,61 minus 90. Put that in the calculator, so it's 420 divided by 323,61 gives you an answer of 1 hour, 1,29 hours. Now if you want to write that in terms of hours and minutes, I subtract the 1 hour. So it's 1 hour. Then this is a representative of 60 minutes. Not so? So I multiply that answer by 60. That gives me an answer of 18 minutes. 1 hour, 18 minutes. Okay? On the other hand, it's going to be 420 over 323,61 minus 90 kilometers. Gives you 1,78, 1,79 hours. Or it's going to be 1 hour. Take the hours away. So that's again a representative of 60 minutes. Multiply that by 60. Gives me an answer of 48 minutes. 1 hour and 48 minutes. Will you guys understand? Don't say yes and you leave here and you don't understand. Let's do it again. Let's do it again? No. Okay. For homework. Out of example 3, we should be able to do number 4, 5, 10 and 15. 4, 5, 10 and 15, and you do me number 9 as well. I'll do number 9 on the board tomorrow as well. Okay? Number 9 doesn't fit with any of these examples, but it deals with what you have done prior to this in your previous grades. Okay? People enjoy the rest of your day. Good morning, class.